Edexcel IAL Chemistry 2025 October Unit 2 Question 1. What color is the solution that forms when iodine dissolves in a hydrocarbon solvent? We can expect iodine to be minimally distorted in a hydrocarbon solvent because it is nonpolar. So we can expect iodine to show its native color, natural color, that is purple. Therefore, the answer is option C. The color is purple. In water, in a polar solvent like water, we can expect a pale yellow color. In iodide solutions, we can expect a brown color because more iodine gets dissolved because of formation of I3 minus complex. But in this case, answer is purple color. Which row shows the correct trends down group 2? We know always the reactivity of elements is increasing in group 1 and group 2. Therefore, we can cut off options C and D. Out of A and B, we have to select the correct combination of answers by considering solubilities of hydroxides and sulfates. Solubilities of sulfates always decrease when you go down, and solubilities of hydroxide increase when you go down. So the answer is option A. Question 3. The gas nitrogen dioxide exists in equilibrium with another gas, dinitrogen tetroxide. This is not a new system for you. This is a frequently met, frequently studied equilibrium system in different lessons. The question is, what happens to the color of the equilibrium mixture when a catalyst is added? We'll see what are the options given. Becomes darker, becomes paler, becomes darker, then becomes paler. So all these are because of the changes to the composition. But in this case, the composition, equilibrium composition, does not change by adding a catalyst. Therefore, the answer is none of the above changes or no change. Which isomer has the lowest boiling temperature? If you look at the 4 molecules given, all are alkanes and all are having 7 carbons. When it comes to alkanes, the boiling temperature is determined by the intermolecular attraction forces, and the intermolecular attraction forces that we can find in alkanes is van der Waals attractions. Van der Waals attractions is dependent on the surface area of the molecule. Surface area, higher the surface area, higher the van der Waals interactions. The surface area is dependent on the carbon chain length and the branching pattern, extent of branching. In these 4 compounds, all are having same number of carbons. Therefore, we have to stick to the extent of branching. And compound A, 2,2-dimethylpentane, is having 2 side chains. 3,3-dimethylpentane, another 2. 2,2,3-trimethylbutane having 3 side chains. Heptane does not have any. So the lowest surface area can be expected with 2,2,3-trimethylbutane. Therefore, lowest van der Waals interactions and the lowest boiling point can be expected with 2,2,3-trimethylbutane, option C. Question 5. Sodium chloride dissolves in water. Which diagram shows the arrangement of water molecules around a sodium ion and a chloride ion in solution? You can see sodium and chlorine is not labeled. You are just provided with a small circle and large circle. You should understand that small circle is sodium, large circle is chlorine, because sodium and chlorine are in the same period. When making sodium plus ions, sodium is losing its outermost electron, which causes the ionic radius to drop. But on the other hand, chlorine is receiving one electron, therefore the charge per the force exerted by the nucleus per electron is decreased, or the ionic radius increases. Therefore, large circle is always chlorine, small circle is sodium, sodium plus. So the small circles should always interact with the negative end of the water molecule, dipole of water molecule. Therefore, oxygens should interact with sodium. Out of these diagrams, B and C are showing that kind of interaction, but A and D does not. Therefore, we can reject the answers. Options A and D. We'll just look at B and C only. And when it comes to chlorine, negative chloride ions are interacting with the positive end of OH dipole, which is shown correctly in option B. But in option C, chloride ions are shown to have interacting with negative oxygen ends, which is not correct. Therefore, the only correct answer is option B. Part B, what is the name of attraction between water molecules and sodium ions and chloride ions? Sodium ions and chloride ions are ions, and water is a permanent dipole. So we can expect ion permanent dipole interactions, option D. Question 6. Which line on the sketch graph best shows the trend in boiling temperature for the hydrides of elements in group C when you go down the group? When you go down the group, these are dipoles. We can see two types of intermolecular attractions in the hydrides of group 6. That is dipole interactions, dipole-dipole interactions, and the van der Waals interactions. When it comes to group 6, the van der Waals interactions are more prominent than dipoles. Therefore, we expect a general increase, because when you go down the group, the size of the group 6 atom is increasing, so more van der Waals interactions expected. Always van der Waals interactions are beating the uh, dipole interactions in group 6, but except the period 2. Period 2 is oxygen and hydrogen bond, which is very much highly polar and have hydrogen bonding. So because of this exception, we expect a very much large increase of boiling temperature when it comes to water molecule. Therefore, the correct answer is we can expect the line P, line starting from point P, to be the correct trend. So the answer is option A. P is the correct point. Edexcel IAL Chemistry 2025 October Unit 2 Question 7. A mixture contains 36 grams of water and 46 grams of ethanol. What is approximately the percentage of water in mixture by moles? Here the masses are given. We have to find the relationship in moles. So we will start with mass and find the amounts and try to establish the percentage of water. So H2O 36 grams to 46 grams, and to convert it into moles we have to divide each value by the molar mass values of each, which is equal to the relative formula mass values in taken in grams. For water, the relative formula mass is 18, so the molar mass is 18 grams per mole. Then we can calculate the molar mass of ethanol, and it ends up as 46 grams per mole. When you simplify this, you will get the ratio as 2 to 1. As a fraction by moles, the water content of this mixture is 2/3, and as a percentage it is going to be 67%. The answer is option A. Question 8. Hydrogen peroxide decomposes as shown, and 20 cubic centimeters of 2 moles per cubic decimeter hydrogen peroxide solution completely decomposes at room temperature and pressure. What is the volume of oxygen produced? Here we are given with the Avogadro's constant, molar volume value, Avogadro's volume, molar volume value, and using that we can calculate the volume. But to find that, we need to find the amount of oxygen that is formed. Amount of oxygen we can see it is as half as the H2O2 which is reacted. So we can find the H2O2 reacted by this piece of data. So we found the amount of H2O2 as 2 moles in 1000 cubic centimeters times 20 cubic centimeters, and as half of that is oxygen, amount of oxygen, and to find the volume multiply that with 24 cubic decimeters per mole. So you are getting a value like 48 times 10 to the power minus 2, which is equal to 0.48 cubic decimeters. Question 9. But1-ene burns in oxygen as shown in a closed system. What volume of gas remains in the system when 20 cubic centimeters of but1-ene burns completely in 20 cubic centimeters of oxygen? So we will build up the stoichiometric relationship between all the gaseous species as this: butene to oxygen to carbon dioxide. According to stoichiometry, 1 mole of butene reacts with 6 moles of O2 and produces 4 moles of carbon dioxide. At RTP, the volumes correspond the moles. Therefore, volumes correspond the amounts. Therefore, we can take the volume ratio as same as the mole ratio or the stoichiometric ratio. So, here they say initially 20 and 200. 20 of butene and 200 cubic centimeters of oxygen is mixed, and at the end of the reaction it says completely butene is burnt. Therefore, you end up with 0 butene. That means 20 is reacted. 20 is reacting with 20 times 6 volume of oxygen. 20 times 6 is 120. So, at the end, the system contains 80 cubic centimeters of oxygen. Then it produces, the stoichiometry between butene and carbon dioxide is 1 to 4. That means 20 to 80. So finally in the system we have 80 cubic centimeters of O2 and 80 cubic centimeters of CO2, which adds up to make 160 cubic centimeters. So the answer is option B. Edexcel IAL Chemistry 2025 October Unit 2 Question 10. Ethanol can be oxidized by acidified dichromate ions as shown, and the reaction balanced chemical equation for the reaction is given here. What is the change in oxidation number for each chromium atom? Here in dichromate, chromium is in its +6 oxidation state and chromium 3 plus is +3 oxidation state, and there is a difference of 3 and that difference is a decrease. So the answer is option C, decreased by 3. 23 grams of ethanol is oxidized by a solution of 0.1 moles per cubic decimeter dichromate ions. Which expression shows the minimum volume in cubic decimeters of this solution needed to oxidize all the ethanol as shown in the equation? So first of all, we can't deal with just grams. We have to convert it into moles. We have to find the amount of ethanol. Amount of ethanol. We can find it by dividing the mass 23 grams by 46 grams per mole, which is the molar mass of ethanol, which you can calculate using the relative formula mass. Using the formula of ethanol C2H5OH, which ends up as 46. And this gives you, when you simplify this, you get the amount of ethanol in this mixture as 0.5 moles. Then we will go back to the equation, and there, according to the equation, the stoichiometry between ethanol and dichromate is 3 to 2. That means if you start with 3 moles of ethanol, then you need 2 moles of dichromate ions to react with that. But we have 0.5, therefore the amount of dichromate required is 0.5 times 2/3. And then we have to go to this piece of data, the concentration of dichromata in solution that we have. According to that, 0.1 mole is contained in 1 cubic decimeter, and we have to find the volume of this much. To find that, 0.5 times 2 divided by 3, this whole thing divided by 0.1. Instead of 0.1, we can write 1/10, and dividing by 1/10, we can write as times 10. So the answer should be 0.5 times 2 divided by 3 times 10, which is the option B. Question 11. A student studies a graph of rate against time for both forward and backward reactions in a reversible reaction. The student makes these statements and 3 statements are given. How many statements out of these 3 are correct is the question. First statement, the reaction reaches the equilibrium. Yes. The forward reaction is fast initially because the concentration of reactants is at its highest. Yes, that is also a correct fact. The rate of both reactions at equilibrium is 0.00 moles per cubic decimeter per second is going to be wrong, because zero rate means the reaction is stopping. Both the reactions are stopping, which is not correct for an equilibrium. We know that equilibrium is dynamic. The forward reaction and backward reaction goes on, it does not stop, but the rates of forward reaction is similar to the backward reaction, therefore the composition of the system does not change. So 2 of the statements is correct. 2 of the statements are correct. The graph shows the change in concentration against time for a reaction. What is the best estimate for the value of rate in moles per cubic decimeter per minute? And the time scale is given in minutes. Concentration is given in moles per cubic decimeter, therefore no unit conversions to be involved. And at 4, the standard way is to make a tangent at 4 to the graph and determine the gradient of that tangent. But here we have to get an estimate that can be done even without doing that. First we will see how to make a tangent and do the calculation. To do that, we can roughly get this value as 0.6 and here 1.2. The difference is 0.6, 1.2 minus 0.6, and the time taken is 4 minutes. And you end up with the answer 0.15. But even without that, you can cut off these values more than 1 by just looking at the graph. The overall change is 1.6 minus 0.4, which is 1.2, and for that the time taken is 6, because that is 0.5. It cannot be more than 1. Therefore, these 2 answers are definitely out. And if you consider the highest rate point, the gradient is 0.4, nearly 0.4. 4, and therefore that value is also cannot be the uh, value for the time at 4 minutes, the rate for the time of 4 minutes. Therefore, that value is also rejected. You are ending up with 0.15. In either methods, you end up with the same answer, 0.15. Edexcel IAL Chemistry 2025 October Unit 2 Question 13. Which test would not enable a chemistry student to distinguish between ethanol and ethanol? Test A. Adding a very small piece of sodium metal to each liquid, sodium reacts with ethanol but not with ethanol. Therefore, this is a valid test. This works. Test B. Adding sodium carbonate solution to each liquid. Ethanol is little bit acidic but still not acidic enough to react with sodium carbonate. Therefore, no reaction with ethanol or ethanol. Therefore, this does not allow you to distinguish between ethanol and ethanol. Test C. Warming each liquid with failing solution. Failing solution is reacting with ethanol, oxidizing ethanol, but not powerful enough to oxidize ethanol. Therefore, failing solution can be used. Adding PCl5 to each liquid, both the solutions are reacting but in different ways. Ethanol gives out HCl, which can be identified using ammonium chloride and the characteristic smell. Therefore, the answer would be option B. Question 14. Which of the statements about C double bond O bonds found in aldehydes and ketones are correct? C double bond O bond is shorter than a C single bond O bond. Yes, correct. The C double bond O bond consists of two pi bonds. That is wrong because it is one sigma bond and one pi bond. Third statement is the C double bond O bond consists of four shared electrons. Yes. Therefore, the correct statements are 1 and 3, option B. Which statement about these structures is correct? All structures show the same compound. Let's see. Basically, these are all are dichloroalkanes. Let's see whether there is a difference in the number of carbons. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you take this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that statement is definitely wrong because this structure contains 10 carbons, whereas this structure contains 9 carbons. And we look at this carbon, this structure also here 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. This is also 9 carbon. And let's see the other statements. Structure 2 and 3 show the same compound. No, structure 2 is different from the carbon chain length itself. Structure 1 and 3 show the same compound. All three structures show different compounds. Out of these two, what is the correct statement? We have to select. Now, uh, both these chloroalkanes are dichloroalkanes, and the chlorine is attached to third and fourth carbons of each chain, and structure 1 and structure 3 are same. This is also 3,4-dichlorononane. This is also 3,4-dichlorononane. Both are the same structure, but the conformation is different. That's why they appear like two different compounds, but they are the same compound. Question 16. Which reaction has a standard enthalpy change equal to the standard enthalpy change of formation of strontium fluoride? What do you mean by the standard enthalpy of formation is what you should know to do this question, to answer this question. Anyway, the formation enthalpy, standard enthalpy of formation involves the energy transferred during the formation of 1 mole of a substance at its most stable form using the appropriate amounts of its all component elements in their most stable physical state. So in that case, we have to look at the components and their most stable physical states. Strontium is made of strontium and fluorine. Fluorine is stabilized at its gaseous form. Strontium is at solid form. Now, all these four reactions are ending up with 1 mole of strontium fluoride at solid state. Therefore, we can't go by the products. We have to stick to the reactants. So, out of the options given, A and C contains strontium at solid state, but A says strontium 2 plus, which is not the ground state of strontium. Therefore, strontium S. The option C is going to be the correct option. Strontium solid plus fluorine gas at 2 gas gives strontium fluoride at solid state. Edexcel IAL Chemistry 2025 October Unit 2 Question 17. A Hess cycle is shown which could be used to calculate the enthalpy change of combustion of propane, which expression is equal to the enthalpy change X shown on the diagram. All the enthalpy values given in the options for answers are in terms of formation enthalpies of water, but the fact is we can't see any formation enthalpy if you consider only this direction of this arrow. But if you change this arrowhead to the other side, you can see it is 4 times delta H formation of water. And because of this change of direction of arrow, we have to apply minus for this direction. So the answer is minus 4 times delta HF H2O liquid. So the answer is option C. Question 18. Which compound will produce a mass spectrum with a major peak at M divided by Z equals 31? If you look at all these molecules, the molecular peaks will be giving somewhere nearly 60. Therefore, we have to uh, break all the compounds in a way that it gives 31. So we can break this one in this position, and the mass of CH3CH2 is going to be 24 plus 5, which is 29. And here CH2OH 3 plus 16 plus 12, which is equal to 31. So this group CH2OH group is producing this peak. Let's see the other ones also. CH3CH 24 from carbon plus 4, 28. Here carbon plus oxygen 28 plus um, 4, it gives 32. And here CH3 CH2 again 29, CHO gives 29. Here it can break in this way. CH3 gives 15, and this part is very much heavy. 24 plus 16, they are 40, 43. So the only answer is option A. The only molecule which can make a piece which weighs 31 is only propan 1-ol, 1-propanol or normal propanol. Edexcel IAL Chemistry, 2025 October, Unit 2, Question 90. This question is about calcium and its compounds. A sample of calcium is burned in air, forming calcium oxide. Complete the equation for this reaction including state symbols. First, we will put the state symbols. Calcium is in solid state, oxygen gaseous state, calcium oxide in solid state. To balance the equation, put 2 in front of calcium and calcium oxide. You get your equation balanced. State the flame color seen during the reaction. The calcium salts are showing orange red color, or you can say brick red color during the flame test. Explain how a flame color forms. How does the flame color forms is the electrons in the metal ions get excited to higher energy states due to energy absorbed from the flame, and it makes those electrons to be unstable. Therefore, they return to their ground state, and during this process, the energy get released as specific or characteristic wavelengths within the visible range, or you can say as distinct visible colors. Part B, the calcium oxide formed is impure because during the reaction, calcium reacts with another element in air, forming a compound. When it says another element in air which can react within a flame, the first thing you should remember is nitrogen. So the compound is calcium nitride. Part C, another sample of impure calcium oxide made from heating limestone has a mass of 5.12 grams. The impurities do not react with hydrochloric acid. The sample is added to 200 cubic centimeters of 1 m hydrochloric acid, forming a solution. The hydrochloric acid is in excess and the reaction is given. The solution containing excess acid, that means after this reaction, is transferred to a volumetric flask and made up to volume of 250 cubic centimeters using deionized water and then mixed. A 25 cubic centimeter sample of this diluted solution is then titrated with 0.15 mole per cubic centimeter sodium hydroxide solution. The mean titrate is 23.7 cubic centimeters. Calculate the percentage purity of the calcium oxide sample. So let's start calculation. First of all, we can find the sodium hydroxide. We can go from bottom to top. First of all, we can find the amount of sodium hydroxide that is reacted, that is equal to the amount of HCl according to second equation, second balanced chemical equation. This one, the stoichiometry between sodium hydroxide to HCl is 1 to 1. Therefore, we can calculate that using this piece of data, the last paragraph, 0.15 m sodium hydroxide and the titrate is 23.7. I have straight away applied the values in cubic decimeters, so the units cancel off, and practicing that way will be more convenient. Then we can calculate the concentration of HCl solution titrated, because this amount of sodium hydroxide is equal to sodium amount of HCl, and that amount of HCl was there in 25 cubic centimeters. That also I have applied in cubic decimeters as 0.025 cubic decimeters, whatever the amount of HCl divided by the volume titrated. Then we can calculate the total amount of HCl remaining after the reaction within this 250 top-up solution. That is equal to this concentration that we calculated in the previous step times the volume 0.25 cubic decimeters, and that I'm getting as 0.03555, and that is the amount of HCl remaining after reaction with calcium oxide in the first reaction. Then we can calculate how much HCl we have added. The amount of HCl that we have added, that can be calculated using this piece of data. 200 cubic centimeters of 1 m hydrochloric acid is added. So that is equal to the amount of initially added HCl is equal to 1 into 0.2 moles, that is equal to 0.2 moles. So the amount of HCl reacted can be calculated by the difference between the amount of HCl remaining and amount of HCl initially added, that I am getting as 0.16445. Then again stoichiometry applies, and the stoichiometry of this uh, balanced chemical equation between calcium oxide and HCl. According to that, this amount of HCl reacted is equal to 2 times amount of calcium oxide reacted. Therefore, we can calculate the amount of calcium oxide reacted by dividing the amount of HCl reacted by 2. That I am getting as 0.082225 moles. After doing this much, then I can calculate the mass of calcium oxide reacted by multiplying the amount of calcium oxide reacted with the molar mass. Always apply with the units, then you will see how the units are nicely cancelling off and you get the answer in grams. And that is the amount of calcium. There is a mass of calcium oxide in this 5.12 mass of impure calcium oxide. So to get the purity, we can divide this mass of calcium oxide reacted by the mass of total sample and multiply with 100. So the answer I get is 90% or 89.93%. Quite pure sample. Part D, calcium nitrate is a white crystalline solid that decomposes when heated strongly with a Bunsen burner. 2 calcium nitrate goes into 2 calcium oxide, 4 nitrogen oxide and 1 oxygen. A student suggested an explanation for this decomposition. What you are supposed to do is identify 2 errors in this suggestion and include corrections that give an explanation of the decomposition. That is the tricky part. You are not supposed to talk about lattice energy. Most of you might misunderstand that you have to consider the lattice energy. Let's see what are the clues in this. What is wrong with the student's suggestion. The calcium ion is polarized by nitrate ion. Something completely misleading. Calcium ion is not polarized. Instead, calcium ion polarizes the nitrate ion. And next part, this distorts the electron cloud around the nitrate ion and so weakens the bond between the two ions. It does not weaken the bond between the two ions, it weakens the bonds, covalent bonds within the nitrate ion. So the corrected statement should be the calcium ion polarizes the nitrate ion. This distorts the electron cloud around the nitrate ion and so weakens the covalent bonds or nitrogen oxygen bonds within the nitrate ion, which causes the calcium nitrate to be able to be decomposed by heat. Edexcel IAL Chemistry 2025 October Unit 2 Question 20. This question is about some reactions of halogenoalkane 1-bromopropane and the reactions of 1-bromopropane with aqueous KOH, ethanolic KCN, ethanolic ammonia are given including the results, including the products. Part A, draw the mechanism for reaction 1, which is substitution, and already you have studied, that is uh, an SN2 mechanism. Include curly arrows and any relevant lone pairs and dipoles in your answer. We'll draw the molecule with the dipole between the carbon and bromine here, delta plus on carbon, electron shortage on carbon, and excess on bromine, delta minus. So because of this electron shortage, lone pairs on OH minus is attacking, OH minus from KOH is attacking on this carbon at the opposite side of Br, and as a result, the carbon-bromine bond is breaking. There can be an intermediate stage where carbon is partially bonded with OH and bromine, but you don't have to show that in this mechanism, and straight away you can draw the product. The product is showing an inversion of the around the geometry around the carbon, first carbon, but a chirality is not there around that carbon, therefore you can't see any difference in the uh, optical activity. Part B. Give the reason why chemists often use reaction 2, the formation of nitrile, when synthesizing organic compounds. So, formation of nitrile means it extends the carbon chain by one carbon. For a lot of processes, we can oxidize this group and do a lot of reactions, as you have learned already in your lessons. So, that is why we are using it in chemical synthesis, organic synthesis. Part C. Give the conditions needed for reaction 3. Anhydrous conditions are needed because water can become a competing nucleophile, and to prevent escaping of ammonia, heating should be done in a sealed tube. A different type of reaction occurs when halogenoalkane 1-chloro-2-methyl-butyl cyclohexane is heated with sodium hydroxide dissolved in ethanol. Explain why anhydrous calcium chloride is added to ethanol before it is used to dissolve the sodium hydroxide. The reason is, if water is there, instead of this expected elimination reaction that we are intending to do, instead we will get a substitution reaction where chlorine is substituted by OH. We don't want that. We actually want the elimination reaction to happen. Therefore, we are making the ethanol not containing any water. So your answer can be anhydrous calcium chloride absorbs water in ethanol to provide anhydrous reaction conditions, as water acts as a nucleophile to result in nucleophilic substitution instead of expected elimination reaction. Draw the skeletal formulae of the three isomers formed in this reaction. We'll take one by one. We can get an elimination done between this chlorine and hydrogen on this carbon, so resulting in this compound, and you can have uh, geometrical isomer for this one as this. And then another elimination can happen. This is not benzene, this is cyclohexane, so there is another hydrogen here. So this hydrogen with this chlorine can participate in elimination reaction to um, give rise to formation of this structure. Edexcel IAL Chemistry 2025 October Unit 2 Question 21. This question is about group 7 elements and their compounds. The compound NaClO3 sodium chlorate 5 is used in paper industry to bleach wood pulp. It is made by reaction of hot sodium chloride solution with chlorine gas, and the reaction balanced chemical equation for the reaction is given. First part, explain in terms of oxidation numbers what type of a reaction occurs. When it gives a hint that you have to consider the oxidation numbers, you can straight away consider the oxidation numbers to state the type of reaction. When it says oxidation numbers, we can what comes into your mind is redox reactions, but this is a special type of redox reactions. You can see sodium, oxygen, or hydrogen does not change their oxidation state, but chlorine is changing the oxidation state in oxidizing and reducing at the same time. We can see in chlorine gas reactant side, it is in zero oxidation state. In product side, it is in two oxidation states. In sodium chloride, in -1 oxidation state, in chlorate 5 ion, in +5 oxidation state. So reduction and oxidation both happens as shown in these two expressions. So this is a disproportionation reaction where the same element undergo oxidation and reduction at the same time. This is a special type of redox reaction. Calculate the percentage atom economy by mass for the formation of sodium chlorate 5 in this reaction. Again, we will take the reaction and we can determine the masses of sodium hydroxide, the molar masses of sodium hydroxide, molar mass of chlorine, and thereby we can get the total mass of reactants as 6 times molar mass of sodium hydroxide, 3 times plus 3 times molar mass of chlorine. It gives us the value of 453. Then we'll look at the desired product. The mass of desired product is molar mass of sodium chlorate 5. Then that is equal to 106.5. The atom economy equals mass of desired product divided by mass of reactants times 100, and this gives a value of 23.5%. A student's test, part B, a student tests samples of sodium chloride and sodium iodide with concentrated sulfuric acid. The following observations are made. Evaluate these observations to decide which halide ion is the stronger reducing agent. Support your answers with the products formed by referring to the observations, the changes in oxidation number to justify your deduction of stronger reducing agent, and ionic equation for the reaction that produces a smell of rotten eggs. State symbols are not required. In both the compounds, with both the halides, when sulfuric acid is added, one common observation is there, that is misty fumes and white smoke. Both the compounds are showing this observation, white smoke with ammonia. So misty fumes is as a result of hydrogen halides, HCl and hydrogen iodide. You can provide the equations for the formation of these compounds, and with these hydrogen halides with ammonia gives rise to ammonium chloride and ammonium iodide respectively, which is shown in these two equations. So this explains the misty fumes and the white smoke with ammonia. Then with sodium iodide, a different observation is there, that is the purple vapor. Purple vapor is indicating the formation of iodine gas that hints that iodide have become iodine. That means iodide ions have oxidized into iodine gas, -1 to 0, and a smell of rotten eggs indicate the formation of H2S gas. The sulfur species that we are introducing in this experiment is sulfate ion, which is at its +6 oxidation state, and that oxidation state drops down to S2 minus. That is a very strong reduction. So for this one, we can give an ionic equation, a complete ionic equation as 8I minus plus 8H plus H2SO4 gives 4I2 plus H2S plus H2O, 4H2O. And this explains why purple color is observed, why rotten egg smell comes is explained by formation of H2S. This set of reactions, this set of observations of um, any other kind of chlorine gas emission is not mentioned. Any observation which hints chlorine gas emission is not there in with sodium chloride, and smell of rotten eggs or any kind of reduced sulfur species is not indicated here with sodium chloride. Therefore, we can imagine that only sodium iodide is showing this second reaction. It does not happen with sodium chloride. Therefore, we can say the observations lead to conclusion that sodium iodide acts as a reducing agent with sulfuric acid, while sodium chloride does not, proving sodium iodide to be the more powerful reducing agent. Edexcel IAL Chemistry 2025 October Unit 2 Question 22. The subactive process uses carbon dioxide and hydrogen to produce methane and water. The reaction is given. The forward reaction which produces methane is exothermic. The process is carried out at temperature of 400 degrees Celsius and at a pressure of 30 atm in the presence of a nickel catalyst. Discuss the advantages and disadvantages of using such high temperatures and pressures in the process. So we can see the forward reaction which produces methane is giving rise to reduction of number of gaseous species present in the system, therefore increasing the pressure according to Le Chatelier's principle, which states if a dynamic equilibrium is disturbed by change in the system, the system shifts its equilibrium position to counteract the change and restore the balance. According to that, increasing pressure enhances the forward reaction to reduce the pressure, which produces the lesser number of gaseous species. Therefore, we can say the equilibrium shifts to the right. Therefore, the yield of methane is increasing. But always with high pressures in industrial environments, it is associated with high risk of accidents, high risk of leakage, high risk of explosion, and high initial cost for the construction of the reaction systems, because we have to use materials which withstand the pressure of the reaction system. Therefore, moderately high pressures, which is optimized to get the desired rate of methane production, is used, which is, as the question says, which is 400 atm. The forward reaction is, on the other hand, exothermic, but that means, according to Le Chatelier's principle, if you increase the temperature too much, It enhances the backward reaction to reduce the temperature of the system. That means reduces the extent of methane production, or we can say the equilibrium shifts to the left. Therefore, too much high temperatures are going to be not favorable for the production of methane. But in this system, to keep up the rate of production of methane at an optimum level, a moderately high temperature should be used, because we have to provide the activation energy required for the gaseous atoms, gaseous species to react, gaseous molecules to react. Therefore, moderately high temperatures should be used. Too much temperature can shift the equilibrium to backward to the left and cause a reduction in extent of methane production. Part B, state how a catalyst increases the rate of a reaction. Simply, catalyst increases the rate of a reaction by providing an alternative reaction pathway with a lower activation energy. Edexcel IAL Chemistry 2025 October Unit 2 Question 23. This question is about alcohols and related compounds. Propan 2-ol is a secondary alcohol. One of its uses is as a solvent to clean the surfaces of vinyl records. Propan-2-ol can be oxidized to form the ketone propanone in a laboratory. However, most propanone produced in the industry is made using cumene process, where hydrocarbons from oil are used to synthesize cumene. Then cumene is oxidized directly to form phenol and propanone. Propan 1-ol is also a solvent and can be used as a fuel. The fuel biopropanol, which is mainly propan 1-ol, is formed from glycerol, a waste product of biodiesel production from plant oils. The reaction is called hydrogenolysis and requires catalysis containing nickel, tungsten, and zirconium. Part A, state what is meant by the term secondary alcohol. A secondary alcohol is an organic compound where a hydroxyl group is attached to a carbon atom that is bonded to two another carbon atoms, or you can say alkyl groups. Part B, the oxidizing agent used to oxidize propan-2-ol in a laboratory is an acidified solution containing dichromate ions. The reaction mixture is placed in a pear-shaped flask and heated for 30 minutes. Give the name of the additional piece of equipment needed when heating the reaction mixture for this length of time without any loss of mixture. In this kind of heating of volatile substances, or even sometimes prolonged heating of aqueous solvents, we include a reflux condenser to minimize the loss of contents in the system. Describe the color change that occurs during this heating. We are starting with dichromate ion, which is having a bright orange color or vibrant orange color, and it is getting reduced down to chromium 3 plus with a green color. So the color change would be bright orange to green. Describe how the IR spectrum of reaction mixture would change during this reaction. Your answer should consider only the organic reactant and product. The organic reactant here is alcohol group, which contains carbon oxygen stretching and carbon hydrogen stretching respectively at 1000 to 1300 and 3200 to 3600 per centimeter, and these are going to be disappeared from the IR spectrum of the propanone. And in the propanone IR spectrum, you can see an additional C double bond O stretch which lies near 1700. Carbon hydrogen stretches almost do not change. Part C, the cumene process is shown using molecular formulae. Benzene plus propane becomes cumene, and cumene plus oxygen, you get phenol and propanol. Calculate the mass of benzene in kilograms needed to produce 2000 cubic decimeters of propanol using cumene process. You should assume that the overall yield of the process is 85% and density of propanol is 0.784 grams per cubic decimeter cubic centimeter, that is equivalent to 0.784 kilograms per cubic decimeter. So I'm going to use that value to get the mass of propanol required in kilograms. uh, I can calculate, if I take in that way, I can calculate it directly. So simply I have to multiply 2000 cubic decimeters by 0.784 kilograms per cubic decimeter. Then that mass, to get that mass, since the yield of the process is 85%, to get that mass, we have to produce more. So to find how much exactly, we can multiply that value, the mass required, by 100 and divide by 85. Then we can get a ratio between benzene and propanol. By stoichiometry, it is 1 to 1, and by mass, it is 78 to 58, the molar mass ratio. Then I can calculate the required mass of benzene in kilograms, the required production of the theoretical yield required of out of propanol times 78 divided by 58. So I'm getting a value of 2480.8 kilograms as the mass of benzene that I have to start with. Most chemists would say that step 2 of cumene process has an overall percentage atom economy by mass of 100%, even though there are two products. State what can be deduced from this comment. Okay, let's go back to the step 2 and see. If you carefully look at the thing, propanol mass is very low compared to the other product, but still the chemists are saying that it is 100% efficient, 100% atom economy process. Carefully look at the question, they are not specifying what is the desired product. So when it comes to industry, the processors, when we are selecting the processors, we are looking at the byproducts also. If you look at the byproducts, or if you consider the propanol as the main product, look at the byproduct is phenol, which is also having lot of applications in the industry. So we can say, as the desired product of the industrial process is not specified, both the products can be considered during atom economy calculation. Both the products, propanol and phenol, are widely applied industrial chemicals. Therefore, the reaction can be assumed as a zero waste process where atom economy is 100%. Edexcel IAL Chemistry 2025 October Unit 2 Question 23 Part D. Data about some physical properties of propan-2-ol and propanone are shown. Boiling temperature and solubility data are given. Compare and contrast these physical properties. Justify your answer in terms of intermolecular forces. Descriptions of how intermolecular forces form are not required. So both propan-2-ol and propanone are small 3 carbon molecules Therefore, because of this small size and permanent dipole nature, they interact with water molecules. Therefore, they are fully miscible. The intermolecular attraction forces involved are with propan 2-ol and water form hydrogen bonds, and permanent dipole interactions between propanone and water molecules. Van der Waals interactions are negligible when it comes to this kind of small sized, small alkyl group containing molecules. Then moving on to boiling temperature, between propan 2-ol molecules there are hydrogen bonds as alcohol groups are there, which are highly polar, and in propanone it is carbon double bond O bonds, which makes the molecule a permanent dipole but not causing hydrogen bonding. Therefore, as expected, the boiling temperature of propan 2-ol is increasing because more energy is required to overcome the intermolecular attractions between propan 2-ol compared to propanone. Therefore, the boiling point is higher in propan 2-ol compared to propanone. Part E. A copper calorimeter containing 200 cubic centimeters of water at 20 degrees Celsius is heated using a sprit burner containing biopropanol. A mass of 1.02 grams of biopropanol is burned during the experiment. Calculate the maximum temperature in degrees Celsius of the water at the end of the experiment. You should assume that there is complete combustion and that all energy produced is transferred to water. Specific heat capacity is given, but most probably this could be a printing mistake in the paper. The specific heat capacity is given in units joules per Kelvin per mole. It should be corrected as joules per Kelvin per gram. And delta H conversion of biopropanol is given, and assuming that biopropanol is 100% propanol, we can start our calculation because we need to know the molar mass value which can represent biopropanol. So for that, I am going to use the molar mass value of propanol by assuming biopropanol is completely propanol. So that value I'm getting as 60 grams per molecule. I'm dividing the mass of biopropanol burned, that is 1.02 grams, by 60 grams per mole to get the amount of biopropanol that is burned, because I know the molar enthalpy of biopropanol. So I should know the amount of biopropanol actually burned in this experiment. To do that, I can multiply the molar enthalpy by the amount of biopropanol that is burnt. Then I can equate that value to the energy required to increase the temperature of water, as in the question it is allowed to assume that complete combustion happens and all the energy produced is transferred to the water. So in that case, I am getting mc delta theta for water equals the energy produced during combustion of biopropanol in this experiment. By burning 1.02 grams of biopropanol, whatever the amount of energy is produced is completely used to uh, increase the temperature of water. That is what is our assumption. Then I'm going to apply the values. In that case, I'm finally ending up with the equation T1 minus T2, that is delta T, equals minus, I have converted the joules per mole value, kilojoules per mole value, molar enthalpy value into joules per mole for the convenience. So the units cancel off, and when I simplify this equation, I'm getting the delta t value as minus 41.09. When I simplify that, I'm getting minus T2 equals minus 41.09 minus T1. This is a difference of temperature in kelvins that is equivalent to a difference of temperature in degrees Celsius. So straight away I'm converting that into degrees Celsius. So I'm getting T2 equals 41.09 degrees Celsius plus 20 degrees Celsius, and the final temperature is 61.09 degrees Celsius, the final temperature of water. Biopropanol has a higher octane number than bioethanol. Name the process carried out on alkanes obtained from crude oil to increase the octane number of a fuel. So in your curriculum, you have learned two processes which increases the octane number of a fuel, catalytic reformation and catalytic cracking. If it is a high molecular weight compound, we can use catalytic cracking to increase the octane number. And if it is a simple cyclic molecule or an isomer which is having a poor octane number, to improve that, we can use catalytic reformation. So the answer would be catalytic reformation or catalytic cracking, as the what type of alkanes that we are using, that we have to work with, is not specified.